Sponsored by Catchpoint, the leader in digital experience management.
Hi, I'm Chris Lopez, Technical Marketing Engineer for Catchpoint. For today's tech tip, I'm going to be pivoting away from our line items and focusing instead on the underpinnings of Catchpoint's monitoring solution. As you know, Catchpoint's synthetic monitoring is powered by a number of different node types, each one with pros and cons depending on the situation. Today, I just want to focus on two: backbone nodes and cloud nodes. These two are the most common node types used in synthetic testing, and our goal today is to provide you a quick reference guide so you can use both of them more effectively. Over the course of this video, I'm going to go over what these nodes are and how they're configured, the pros and cons of using either one in a synthetic test, and then scenarios that play to both of their strengths. And as I go through this, please remember that the ideal digital experience monitor is one that offers multiple node types, so that way you can tailor the best one to the situation in hand. All right, let's hop in. So before I dive into backbone versus cloud, let's contextualize what we're doing with these nodes and why. When it comes to your user experience, you need to consider four things with your digital experience monitor: reachability, availability, performance, and reliability. Reachability, as in, can we even get from point A to point B? Availability, as in, is my application up and running? Performance, as in, how well is the application doing so far? And reliability, as in, can we get good readings on all these metrics consistently? If you can achieve stats for all four of those things, you have a successful DEM solution. So keep this in mind as we move forward. Catchpoint offers synthetic monitoring, meaning that it can record and replay something like a web transaction and then quantify network data from the results. For example, if I run an e-commerce store and my clients are having their traffic dropped whenever they try to check out or add something to the cart, I'd use a synthetic test to replicate that transaction and then have it tell me what step the users failed at. Catchpoint offers 830 external monitoring stations to perform synthetic tests from. When you're building a synthetic test, you need to decide what type of node you want to run it on. These nodes are standing in for your user in this test, and while you'll find all of them can perform similar tasks, you'll also find critical differences based on where they're hosted and what data you can pull off of them. With that in mind, let's move on to the next section, which is when to use backbone versus cloud nodes. If you're hosting applications in the cloud, then synthetic monitoring with a cloud node is faster. Catchpoint nodes hosted in AWS can test cloud nodes faster than backbone because there's less overhead. Both the node and the application are inside Amazon's network, so it doesn't need to be passed between different providers in order to reach the end. In that sense, cloud nodes help you determine whether or not your application is available. This also means you can evaluate how well your cloud providers are serving you. If there's any doubt as to the reachability or availability of your cloud-hosted application, then running a synthetic test from your cloud node to your network expands the surface area that you're monitoring. And if you don't think your cloud providers are meeting their SLAs, that same test is going to tell you exactly how they're doing. Finally, with any given synthetic test, Catchpoint needs to look at a lot of elements, paths, and files when it's doing things like loading a page or loading associated images. Cloud nodes are fantastic for scenarios where you need to run a large volume of tests, as they are a lower cost option that can scale more easily with such requests. Now, when it comes to backbone nodes, you're going to notice a slightly different set of strengths. Backbone nodes are deployed on high-speed lines inside Tier 1 ISPs. You know, the guys that build infrastructure that feeds the Tier 2 and Tier 3 providers. They also have local DNS resolvers inside the data center, and their goal is to provide you information from beyond the demarcation line, or beyond the firewall, so to speak. Backbone nodes are the bread and butter of synthetic monitoring, and they'll always be the first type of node we recommend for a synthetic test. Specifically, they keep the end user in mind. Backbone nodes test your application in the context of the end user's experience. Now, if you wanted to know whether or not your cloud-hosted application is available, a cloud node is going to give you perfectly fine data. But if you want to know whether or not your user base in Mumbai can reach your application, a cloud node is not necessarily going to tell you that. They don't need to travel along any networks in Mumbai in order to reach the application. For this reason, backbone nodes are considered ideal for evaluating performance on a geographic basis. Now, consider this. According to HTTP Archive, 93% of web pages have at least one third-party request. The average page has 9 unique third-party requests. And while these requests are getting distributed across the globe in various clouds and data centers, they're also getting interconnected with backbone providers. Right? They provide a mesh of requests that deliver the overall experience. So backbone nodes are prime for this type of monitoring because the odd result isn't going to affect your overall understanding of what your users are going through. Now, this one is more situational than the other bullets, but it's common enough that I feel the need to mention it. As cloud providers manage the environment, your VMs might be assigned different IP addresses, including ones that might have been blacklisted. If they are, they'll get blocked by third-party software because they may have been used for malicious activities in the past. Tier 1 ISP backbone nodes don't have this kind of issue. I'm hopping into the software for this last part because I want to show you how backbone nodes can help you avoid cloud-related routing issues. Monitoring from the cloud adds a lot of variables and points of failure into the equation, and to that point, I have a recent test case. Consider complex routing environments inside of these data centers. Here, in this example, an application was monitored from both backbone and cloud nodes. The routing posture of the cloud node resulted in 26 hops before it reached the application, compared to the 6 to 7 hops from the major ISPs. And I want to emphasize that most of the hops here were inside the cloud itself. Now, obviously, it's not going to be the case every time, but that's creating a lot of noise relative to useful data, and it's probably something you wouldn't want to deal with during a live outage or disruption. Hopefully, you have a clear idea of what either node type is good at, but let's recap the important bits. Cloud nodes are great at monitoring applications also hosted in the cloud. They're great at testing return traffic from the cloud, and they'll tell you how good of a job your cloud provider is doing. But by reducing the scope of what's being monitored, that data becomes less valuable outside of those situations. Backbone nodes are inherently more reliable than cloud nodes because of their built-in redundancies and because of their relationship to the end-user experience. Now, remember in the beginning, I mentioned the 4 core pillars and why they're critical to the digital experience monitor. Well, in that regard, backbone nodes are the clear first option to reach for before considering any other node type. There's actually a lot more types of nodes, and I'd love to go into them, but that's all the time we have for today, so thanks for stopping by. I'll see you next time.
Sponsored by Catchpoint, the leader in digital experience management.